Hi, in this video we're going to find what's called the least common multiple. It's also sometimes you find it here as the lowest common multiple. And we'll just abbreviate it as the LCM. Okay, here we go. Now, what I want to do is, remember when you first learned to count? For example, when you counted by twos, you would count 2, 4, 6, and so on like that. Okay. So, in order to find the lowest common multiple, all you do is count by those numbers. So, for example, let's try this problem. Find the LCM of 6, 15, and 9. So if I was to count by sixes, I would say start with 6, and I have 12, and then 18, 24, and I'm not sure how far to go, so let me stop there for a bit. 15. So I wanted to count by 15, so I would go 15, 30. Wow, that went right past my 24 up above from the sixes. So let's keep going. 30, 45, 60, 75, 90, and we'll try one more. How about 105? Okay, now let's try this by nines. We'd count 9, 18, and now notice the 6 also shared an 18, but the 15 doesn't have any 18, so we have to keep going. 9, 27, 36. Now notice the 15 doesn't have any of these. Then 45, well the 15 has a 45. Let's see, maybe the 6 has a 45. Let's go back to the 6 for a moment. So 24, let's count again. 30. Oops, that looks kind of funny. 30, 36, 42. We're going to skip 45. We're going to go right to 48. Let's count for a few more. 48, then 57, oh, I'm sorry, I'm counting by sixes. I made a mistake. 48, 54, 60, 66, 72, 78, 84, 90, 96, and let's stop there for a moment. And oh, look at this. Now what do we got? We've got, here's a 90, here's a 90. Let's keep counting by the nines and see if we get to a 90 there. So I count by nines, it goes 45, 54, 63, 72, 81. Oh, and sure enough, there it is, 90. And so you would say that, you'd say 90 is the lowest common multiple of 6, 15, and 9. Now, that works for numbers, but what about when the numbers become polynomials? It becomes a little bit more difficult. So before we do that, let's just take a look at how another way we might have done this. So what I'm going to do is list all factors of each number. So let's write that down. We're going to list all factors of 6, 15, and 9. Now, 6, notice I can write that as a 2 and a 3, oops, not a comma, 2 times 3. Okay, 15, 15 is 5 times 3. So here's what I'm going to do. I'm actually going to line these up as I uncover them. So I have a 5. I'll put it, since it doesn't line up with a 2 or a 3, I'll put it a little further out. And I have a 3. And then my next one is 9. Well, 9 is 3 times 3. So I have a 3, but I have 2 of them, so we'll say squared. So the question is, here's what we do, or here's one way to find it. So what we can do is bring down each column and bring down the highest count. So let me explain. In this case, there's a 2 in the 6, but not in the 15. There's 0 2s. And in the 9, there's also 0 2s. So the highest count of 2s is 1 2 from the 6. So 2 times. Now, when we come to the 3s, there's the 6 has 1 3, the 15 has 1 3, but the 9 has 2 3s. That's the highest count of 3. So we need a 3 squared. When we come to the 5s in the next column, 6 has 0 5s, 15 has 1 5, and 9 has 0 5s. So the highest count of 5s is 1. So we need 1 5. So let's put these numbers together and see what we get. This is going to be 2 times 9 times 5. Well, we do know that the easy way to do this is 2 times 5, that's 10, times not there, it is 90. Now, that's how it works with numbers, and it's a little bit more comfortable for most of us to see. So now, let's try an extension. Let's try this for polynomials. So the problem reads the same. Find the LCM of x squared minus 4, x squared minus 5x plus 6, and x squared minus 9. Now, in order to find the lowest common multiple, we have to factor each of these. So factor each one. We'll call it each polynomial. Okay. Well, x squared minus 4. Let's factor that. So x squared minus 4 is, look, if you think of it as x squared minus 2 squared, then it's a difference of squares, and so it factors into x plus 2, x minus 2. Okay, x squared minus 5x plus 6. We actually did this in an earlier previous video. So x squared minus 5x plus 6. I'm going to line up my columns here. It factored into an x minus 2 and an x minus 3. X squared minus 9, you might recognize it also as x squared minus 3 squared. So it's a difference of squares as well. So that means I'm going to have an x plus 3. Now notice I don't have an x plus 3 column yet. So I'm going to start a new column. I'll put my x plus 3 here. Times x minus 3. Well, I already have an x minus 3 column, so let's use that. So look at what I have. My first column is x plus 2. And I have 1 x plus 2 for the first polynomial, none for the second one, and 0 for the third one. So let me get rid of that mark. So I need an x plus 1, x plus 2. If you look at the next column, we have x minus 2's. Notice that the first two polynomials each have 1 x minus 2. The third one, x squared minus 9, has 0. So we need 1 x minus 2. When we come to the next column, we have x minus 3's. The first polynomial has none, but the next two each have 1, so we need 1. And finally, when we come to the last column, x plus 3, we have 0 in the first polynomial, 0 from the second, but we have 1 from the third. So we need 1x plus 3. And this, the product of all 4 of those binomials, is the lowest common multiple. Now, you could multiply all these back together. You'd get a polynomial with an x to the fourth, and an x cubed, and an x squared, and an x, and some number. But that's really complicated, so I would suggest you always leave your lowest common multiple in this factored form. Okay, so leave your lowest common multiple in the factored form. Okay, let's stop there. And in our next video, we'll try a couple more examples. All right, thank you for watching.